Hello CS112. Today I'll be going over a quick solution to Lab 8, which has to do with recursion. So I'll be going over two different solutions to Lab 8, the first using global variables and the second not using global variables. Either way, let's dive right into it. So you had to create a definition called isSequenceValid. Given a string s, you need to determine if it's valid. What makes a string valid? Well, the string that could look something like this needs to have the substring AUG and one of these three substrings within it in order to be valid. So that means that if it had AUG and none of these, that would be invalid. If it had all three of these but not AUG, it would be invalid. Something else that another TA brought up to me is apparently in the world of biology, the codon AUG comes before the other codons because AUG is considered a start codon. So we can go ahead and assume that AUG comes before these three. I think that definitely is something that should have been mentioned on the sheet, but it wasn't because that, in my opinion, is not common knowledge. But all right, moving on. So the typical structure for a recursive function is you have your base cases and then followed by your recursive cases, and typically some sort of maybe some checks or calculations in between. So for my global variable, this is my global variable, excuse me, solution. The first thing I like to do while I write my recursive functions is first come up with base cases. Well, we got to think about theoretically how we're going to solve this. So we are told we want to be doing this recursively. So I can check, I can index a string because strings are just lists of characters in Python. So I can index this string. I can check, in this case, S0, S1, and S2, and check them three at a time to see if they are AUG. Once I find AUG, I can then just check if UAA or UAG or EGA is in the rest of the string. That's easier said than done, so let's just dive right into it. So since I'm going to be checking, like sort of hard coding that I'm checking the first three characters at a time, I'm going to be slicing these off every single time I call S again when I don't find what I'm looking for. So what do I mean by that? You guys should know what slicing is by now, but I'm going to write my base case first. So since I'm going to be making the string smaller and smaller, once I have reached an empty string and I haven't returned valid yet, that means that it's invalid, right? Because I haven't found anything. So I'm going to be saying if the length of S is equal to 0, that I can return invalid. All right, so that's my only base case for this function. Obviously, other functions you're writing could have it. You could make this a bit faster and even check when there are like 2 left, because if there are 2 left, that can't form a string of 3, so on and so forth. But I'm just going to leave it at 0 for explanation's sake. Now my recursive cases, like I said before, I want to continuously make this string smaller. So how do I do that? I use slicing, and I want to be getting rid of one character at a time as I recall isSequenceValid. Now I don't know if codons are required or like destined to be in groups of 3 character letters, but I'm going to assume that they're not because I'm not a biologist and I have no idea. So why I'm doing it by 1 character at a time instead of 3? Well, you could be passed through a string that's like AUG, and these are your first 4 characters. Well, if you look here, there is an AUG right here, but if you keep slicing by 3, you're just going to get rid of that and just read the first 3. It's not there. All right, let's get rid of it, and you're going to continue, which is not what we want. So we're going to check. We're going to return a string just minus 1 character so we can be really thorough with our work. Now it's really important that you return isSequenceValid with S, because if you just call isSequenceValid without the return statement, you're not actually doing anything. You need to return your recursive call. I'm going to say S, and then I'm going to return that string from the first index onto the end, which is what this does. I'm sure you guys know slicing by now. So all I've done so far is I am repeatedly making the string smaller, smaller, and smaller until I have reached the length of 0. So obviously it's not actually checking right now. So that's what our next portion is going to be, is actually checking these strings. So I'm going to paste some global variables I had copied and cut before because I didn't want to have you guys watch me type all these things up. So you can see here I have a start variable, which is your start code on AUG, followed by the other three variables up here. And then I also created a start flag, which is a little Boolean flag, which I actually used a lot in my coding projects to let me know if I have found AUG yet. So right now I've set it equal to false, obviously, because, well, it's I'm going to assume I have not found it yet. Now, once I find AUG, I'm going to set this equal to true within this function. And now, I'm sure you guys know what global variables are. It's just a variable created outside of any definition in your code. Now, you can access these and view them within these definitions, but to actually modify them, and we're only going to be modifying start flag in this case, you need to use the global keyword. So I'm going to say global and then start flag. Yikes. Global start flag. This will allow me to actually change the value because I want to change it to true if I find AUG. I'm not going to be changing any of these other ones, so I don't need to call it globally. Or I don't need to call the global keyword on the variable. So now are my calculations between the base and recursive cases. So I want to check, first I want to check if, like I said before, I'm going to be making the string smaller and smaller, and I want to do that by making sure that I haven't found any of these guys by checking if AUG is within S. And I'm going to be checking the first three characters to check that. Excuse me. So I can say if start is equivalent to the first three characters. And I can do that by doing something like this. And I'm actually going to say in. I'm not going to say equals equals. I'm going to say in to, just to stay a little consistent with what I'm going to be doing later. So I'm going to say if start, which is AUG, is in the characters from the beginning of the string all the way to the third index, non-inclusively, I believe. So I would check 0, 1, and 2. If 0, 1, and 2 is AUG, then we are going to set our start flag equal to true. Now we know that AUG is within S. So now our next thing is we also need to check if there are the other substrings. So I want to first make sure if start flag, because I can just say if start flag and end it there, because start flag is a Boolean flag. It's either going to equal true or false, so this will either be if true or if false, and followed by an and statement that will really secure that this will work, because if this is false, the Python interpreter won't even read what's beyond this and statement because this is false. So now moving on, we need to check if AUG is in S and one of these other substrings that are in S. So since I'm going to be checking a bunch of different substrings, I'm going to wrap these in parentheses just to make sure my logic is airtight. And I'm going to say stop 1 in S, or stop 2 in S, or stop 3 in S. So right now I'm checking if one of the three variables is in S. That's why I'm able to use the or here, because only one of these three needs to be in it. And to reiterate, you need to check if each one of these variables is in S. You can't just say if stop 1 or stop 2 or stop 3 in S, and you check every single variable. And then lastly, this is when I would return valid, because, well, we have found start flag, which is our AUG, and we have these in S. So let's just test this out, shall we? I'm going to uncomment this, and we get an error, which is great. We can debug this together. Yes, I said a sequence blade. That's not not what we did. Okay, so I'm just going to click last, and okay, it works. We got valid. So now, why am I using Python Visualizer today? Well, I actually learned how to do recursion myself by studying Python Visualizer's little GUI here of the call stack. So every time you're within a recursive function here, these arrows will tell you what's up. Every time you call itself, it will add that call onto the recursive call stack. And you can see here, I returned S, but I'm now missing the first character at the beginning. It took off one of the U's. And as I keep going, another U is taken off, the last U is taken off in the beginning, so on and so forth. So look at that. It keeps going, it keeps going, it keeps going, until obviously we can examine this and be like, all right, these first three are AUG, and it has another codon, and then this will be the last recursive call. But now what happens when you actually return something? So obviously we now have start flag is going to be equal to true. As you can see, it's false here. I'm going to click on the next line, and it's set equal to true. That means this is going to be entered. So it's going to have the start flag equal to true. So it's going to say if true, and it's going to check if any of these other three are in S, which it is. So it's going to return valid. So boom, this has a return value now. So again, I'm using these return keywords whenever I'm calling, especially in my recursive case. I need this return thing. So now it's going to start popping off these calls to the stack, passing the return values to each one. So boom, passed, 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 all the way to your very first call. And it's just going to give you the return value valid. So now I'm going to test the second function here. Actually, let's test, I want to test 3 first. I'm going to test test 3 first to show you guys, a lot of you guys are running into this error about specifically while using global variables and testing for an invalid sequence. So if I go last here, it's valid. How can this be valid though? Well, it has one of the other substrings in it, UAA, but it doesn't have an AUG. And why is this? Well, that is because you are using a global variable. So when you first called a sequence valid on this string here, we set start flag equal to true. Whenever this is done executing, since this is a global variable, it will keep that value. So now the next time it's called with this string right here, it's already going to assume that it is true that the start codon is in this string, even though it's not. So when this is called, it's going to go right here. Well, the length of this is not 0. If start in S3, well, it's not in, so it's going to move on to here. And if start flag, which is true from the last time we called it, is true, which it is, and one of these other things are in S, which it is, UAA, then return valid. And that's why it's returning valid twice. So how can we get around this? Well, one, you can either not use global variables, or you can just test it one at a time. And as you can see here, it's invalid because we started with the original value. So that being said, I'm also going to test 4 while I'm here. And there we go. I got 2 invalids, which they both should be. It's always good when you're writing recursive functions to test your base case, which is what I'm doing here. I'm going to delete the invalid test cases now that I've proven them, and then I'm going to run it with just the 2 valid cases. As you can see, these are essentially the same string, except I changed the substring within them to tell you, to just see if it detects different substrings. So that was the solution of using global variables. I'm going to dive into the solution not using global variables now. So I'm going to delete these. I'm going to delete my solution here, although it is very similar. And I actually wanted to keep my test cases. I actually want to keep my test cases. Okay, I'm going to keep these test cases. Then I'm going to comment them out. All right, and then I'm going to get rid of all my code and all my global variables. So, similar structure as before. You first, in a recursive function, you have your base cases, and then you're usually followed by some sort of checking or calculations, and then you have your recursive cases if you have multiple recursive cases. Now, similar algorithm to before, we're going to constantly be checking the first 3 characters and then squishing it by 1 character at a time to recursively find if UAG is in it. And if we find UAG, we can simply check if one of these other sublists is in S. So the base case, like last time, is if the length of S is equal to 0, we're going to return invalid. Now, if you just skipped ahead to this solution, the reason I'm doing the length of S equals to 0 is invalid was because I just said we're going to be continuously slicing the string and making it smaller and smaller and smaller as we don't find S, or if we don't find a valid string. That means that if we remove enough characters to get an empty string, well, that means the string wasn't valid. So we can return invalid. Now, in my previous solution, I also pointed out sort of a second base case, but that's going to come after we do a little bit of calculation. So we all know that we can index a string. So I want to check if we first three strings are, or sorry, the first three characters are equal to AUG. So I want to say if AUG is in the first three characters of S, I can, well actually, I'm sorry, since we're not using global variables here, I'm still going to do that actually, but I need to check if the first three variables, or the first three characters are AUG, and we have, I'm going to slap these in parentheses again because I have to do three different checks here. Actually, you don't know, I'm going to split this up. So, if AUG is the first three characters, sorry, if AUG is the first three characters, we're then going to be checking if any of these other characters are in S, and we can simply do if UAA in S return valid. And we're going to do this 3 times for each of the other cases. So I'm going to copy and paste these so it's easier on myself. So we have the UAA, we need UAG, and we need UGA. So now that we have all of these guys together, again, what this is doing is you're going to be checking the first three characters. If that equals AUG, then you're just going to be checking if any of these other three are in S. Now, yes, you guys can just say if AUG in S, if blah, 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 but that won't make it recursive, and we wanted you guys to solve this with a recursive solution. So now, these are calculations slash, technically also base cases because we're returning something here. Now, for my recursive cases, I'm going to just, again, you need to return your recursive case, but, well, I already typed recursive cases up here, but you need to return your recursive case, so return is sequence valid. And like I said, I want to remove it one character at a time. The way I would do that is 1 and then empty. So what this is doing is it's slicing the string from the first index onto the end. When you have nothing after the colon, that implies that you want the rest of whatever you're slicing. Similarly up here, if you don't have anything before, that assumes you want to start from the beginning of what you're slicing to the end. So yeah, let's just test this bad boy out. And let's test our logic here. Okay, I got the expected outputs, but again, in case you guys skipped ahead, I'm going to explain why I'm doing Python Visualizer again. Well, this is literally how I learned recursion. So every single time that you return you return a recursive call and a recursive function, it's going to be added to the program stack here along with what you called it with. So as you can see here, I've already sliced off the first U. I have 3 U's here, now it's only 2. And as I continue and keep going, it's going to keep getting smaller and smaller and adding my call along with what I called it with to the return stack. And you keep going. Well, now we've reached the case where it's AUG, and we know that UAG is also in here, so this is true. So this should be the last call that we have here. So if you check the arrows here, this is finally true, so it's finally entering here, and it's going to find AUG, or UAG, sorry, so it's going to read this, it's going to go into here and return valid. So as you can see here, as soon as it entered, it had a return value. This function call had a return value. As soon as it hits that return value, it's going to start popping off of this stack here. Now keep in mind these return values are different than returning the function called self. This returning the function called self adds a function call to this call stack. For returning something else, if you hit a return value, it's going to add that return value to that call and pop it off while passing it through the other function calls. So as you can see here, the valid is being passed through all the way to your very original call here, and you have return valid. And it's just going to continue doing that. If you just power through these real quick, as you can see, it's building the stack. It has reached the end of the stack, it has valid, and now it's popping off the function calls. Same with this. These are going to be a bit longer because these are invalid sequences. As you can see, it keeps on going until it gets all the way down to 1 character, and then it's called with 0 characters, which is my base case. The length of S now should be 0. We'll hit next, and it's invalid. And invalid is going to be passed all the way through, so on and so forth. And yeah, if you guys have any questions on recursion, don't be afraid to leave a comment down below or hit us up on Piazza.